Okay, so this little video is going to be on sum and difference formulas for sines and cosines. Again, I apologize. I am just incredibly sick. So as we go, just a quick reminder: we have Euler's formula. Pay no attention to the variable being used; it's kind of irrelevant. But the format is necessary. All right, so let's go through and let's try to derive a sum formula. I'm going to use alpha and beta. So if I were to do that, that means that my input changes from theta to alpha plus beta. So this is just going to be cosine alpha plus beta plus I sine alpha plus beta. And then we're going to use a little trick here to separate this out, and we're going to say, all right, well, e to the I alpha plus beta, because I'm adding these things, is nothing more than e to the I alpha times e to the I beta. So if I do that, then now I have this, that this is going to be cosine of alpha plus I sine alpha times cosine beta plus I sine beta. So now if we do our dirty four-letter F word all of this, then we come up with cosine of alpha plus beta plus I sine alpha plus beta is equal to, if I play with the reals, okay, so now here's the dirty four-letter F word, right? I'm not going to say it, but there it is. So there is actually a cool thing about using this in the complex numbers. And it always works, so I don't mind using this one. But if you rearrange the letters, because again, we're looking at multiplication, Floy kind of helps you out here. The F and the L, those contain your reals. So that first and last contain your reals. The O and the I contain your imaginaries. So we can help ourselves out here. So my reals are going to be my fronts and my backs. So cosine, this is going to be cosine alpha, cosine beta, minus, now the minus comes from I squared, which is -1, times sine alpha, sine beta. So already we've got the reals, so we've got a sum formula for cosine. And then on the back end of that, we're going to have plus. And now our inside and outside, so this is going to be our I sine beta, cosine beta, or cosine alpha, plus I sine alpha, cosine beta. And then if I combine these two, I can just factor out the I, and I get I, and then I get my sine of beta cosine alpha plus sine alpha cosine beta. So I can come up with now a couple of sum formulas where cosine of alpha plus beta is equal to cosine alpha cosine beta minus sine alpha sine beta. I don't know why I changed up doing that way. And then for sine alpha plus beta, we get sine beta cosine alpha plus sine alpha cosine beta. So you can think of it really as a mix. So sine is a mix. Sorry. a mix of the two products. And then cosine keeps them somewhat homogeneous. So you've got cosine of alpha beta and then minus. Well, that's different because the sign changes. That's kind of interesting. So anyway, there's a sum formula. I will leave it to you to show that, in fact, it's a sum and difference, and all that happens is the sign changes. But I'm going to leave it to you. I expect you to be able to do it. I will give you a hint. Sine is an odd function. So, for tomorrow, you guys should be able to derive the difference formulas. And I'm going to start working on identities for you guys to solve. All right? Okay. This is it. So we've got the double angle formulas down. We've got power reduction formulas. And so, again, if you know the double angle formulas, you know power reduction formulas. So you don't need to memorize those because you already have them in the double angle. The sum and difference formulas, you can kind of sing-song them a little bit. You notice I haven't really tackled any tangents and that sort of nature. It's simply because all you have to do is take sine over cosine. But that can be a hot mess. And so, honest to God, I'll usually switch the tangents to sines and cosines just to make it easier. But anyway, that's it. So tomorrow I want to see, I would like you guys to work on going through and proving these identities for yourself. And then I also want you to work on proving the difference identities. And then tomorrow I'll give you the product of sum and sum to product identities. All right. Good luck. I think you guys can do it.